Okay, welcome to part 2 of the lab on the bridge rectifier. The bridge rectifier is a full wave rectifier. It gathers information during not just one half of the cycle, but during both halves of the cycle. And to use that, we're going to use a bridge rectifier itself. So again, we're starting with our source. This time the source is not going to be grounded though. So this time we're going to pick off the plus and minus of the source, and then we're going to go into the bridge rectifier. So what's inside the bridge rectifier is basically a squad or a diamond-shaped configuration of 4 diodes. One like this, one like this, and they connect together. And this is your positive side. And then we have another pair of diodes like this, and another pair of diodes like this. And this is your negative side. So it'd probably be easier if I drew the load inside the middle here. So that means your plus to minus DC output is here. There's your load resistor. And here's your filter capacitor, like so. Plus is to that side. And this one works in 2 cycles. And Steve has built a very nice demonstration to show this. We'll show that before you get started with the lab. But let's take a look and see what happens when Vs is plus to minus. When Vs is plus to minus, we have a positive voltage here, turns this diode off because the N side is below the P side. And it turns this diode on, and so current goes from there to the output. On the minus side down here, the minus side turns this diode off, turns this diode on, so now current can continue to flow through there, and then back. So that is the route that current takes during the positive phases of Vs. During the negative phases of Vs, we have minus here and plus there. Let's try the other green marker, see if it shows up a little better. So this time we're now going to have a positive voltage over here. The positive voltage here will now turn this diode on and this diode off. So now current is going to come out the positive end, go through there, to the load, and then the negative side here is going to make a negative voltage over there. That turns the diode off, turns this diode on, and so now this current can continue. It can't go this way, that diode's off, but it can go this way and then come back that way. So what we have with this circuit is the diodes are really alternating. You get these 2 during the positive phase, these 2 during the negative phase, and they just go back and forth, and we'll see that with Steve's demo. So for this lab, we're going to set Vs to be a 12 volt peak to peak. Okay, so looking at waveforms. So this is going to be 6 and minus 6. Here's time. And this time what we're going to see on the output is we're going to see full wave rectification. So what we're going to see now is the output comes up and then it comes up again. Like that. So if this is Vs, this is V out. Okay, and that's Vs. And then once you put the filter cap in there, the filter cap is now going to smoothen the bumps. But what's nice about it now is that we're only going to decay down that far, whereas with a half-wave rectifier, we would have decayed all the way down to there. So this, the capacitor is replenished twice in a cycle instead of once, and these give you less ripple, they give you better performance, and they're more energy efficient. So the equation we're going to use, VR is equal to VP over 2FRC, because now we're replenishing twice in a cycle, so we're doubling our frequency down here. Everything else stays the same. So what we're going to do for this lab is we're going to set our VP, we're going to set this here as 12 volts. Peak to peak, and we're just going to see what kind of a voltage we get on the output. And I believe we also had 100 millivolts of ripple. So we can again use that to calculate our capacitor value and see what we get. One other thing that we have to take into account is that we're always having 2 diode drops on the output. So we have 2 diodes on, we're losing 2 times 0.7 volts. So we should now expect this voltage to be not just 0.7, but 1.4 volts below the peak to peak. So we are going to be down to 5.3, 5.3. So we're taking a 12 volt signal and we're coming out with a 10.6 volt signal. We're losing 2 diode drops instead of just 1. But in the grand scheme of things, that 0.7 of a volt is not that big a deal, especially if you're dealing with a higher voltage than this. So with that, we're going to go to the circuit board. We're going to build this using a diode rectifier, a bridge rectifier chip, which looks like this. It has 4 pins, and I have discussed these already in lecture, but these pins will be labeled. There'll typically be a plus and a minus, and an AC and an AC. The plus is this terminal here. The minus is that terminal there. These two are the AC, and it doesn't matter which is which because AC is AC, whether it's upside down or right side up. So we're going to use a device like this, which has all 4 of these diodes built and wired into one package. Saves us a little bit of construction. So with that, we'll go to the circuit board, build this thing, set up the voltage source, and watch it work.